Yes, recording in progress. Really short introduction from my side. Recently, hello everyone. We're 7 people gathering here for introduction into custom data type registration in VL Kairos, this timelining framework by Nathan. And yeah, recently I was reaching out to Nathan because I wanted to know more about this feature. It has not been covered in any of the node workshops yet. And I think it's a really nice concept. And yeah, from what I imagine, it's really powerful. So yeah, we decided to record the session and invite others. So Nathan, please show us what you've got.
Yeah, okay, we can have a look at this feature, which, yeah, I also didn't really explore much. Didn't have time to implement many other types. But yeah, it was at the core, basically, of the conception of Kairos, having a framework that allows you to just apply the principles of how you want to control things to whatever you want. So it could be also your custom data type or anything. So yeah, I guess we can start. I'll share my screen, and we are back in theory land. No, just a very quick reminder, so to say. We're talking about Kairos, which is a library that is built on top of other libraries, which are Alchemix, LayerX, and yeah, and that's it basically. There is the core of Kairos is the runtime, and then we have Kairos containing the UI and the editors for the core functionalities. But yeah, so it's like so to say, a nested structure of libraries, and it's important to keep in mind this structure because everything that we do operating at the Kairos level, it's simply an implementation of what's underneath, so the other libraries, which means that if we want to implement and make use of our custom data types into Kairos, we need to make sure that we provide support at the underlying library for that custom data type. So yeah, just to refresh, what is Alchemix? Alchemix, oh wow, this is quite broken. Alchemix is it's a library that allows you to mix together different instances of a type, which means that you can the main functionalities are like interpolation between two instances, like a lerp, so to say, and then blend. You can blend between different instances, having different blend modes like additive, subtractive, dark, light. Yeah, something that should sound familiar from, I don't know, different Photoshop layers. And the purpose of this library is that you can have basically full control on how you compose two instances of your type on top of each other using deciding some blending algorithms and then some alpha transparency to basically blend between them. And this compositional aspect of it is really the core functionality of Kairos in the end. The core functionality that gets used at the LayerX level, because LayerX is another library that introduces, I think this is not the most up-to-date version of this mirror board, but anyway, this LayerX introduced some other concepts so that you can place something, some instance of your type into a space that then you can sample. So this allows you to locate things into, for example, in an interpolator, which is, imagine a timeline. No, you can put keyframes or clips, and then you move your sampling position, and then you can operate with this. So this library introduces all these concepts of being able to place some values, some instances of your type into some framework, which involves space and ways to sample this space. It can be a one-dimensional space, a 2D space, or like a switch or whatever. But anyway, then we end up in Kairos, which is the high-level tool that allows you to treat things as we are used to, like with a launcher, like clip-based or a timeline. But what we really, this is what really get used underneath. So in order to allow our data type to be picked up by Kairos, we need to provide support for these libraries, and which means that we need to support, we need to provide some functionality so that we can, VL knows how to, for example, to interpolate between two instances of our type, or knows how to blend between two instances of the type. As you see here, for example, we are providing a color, or here a float, here a vector. Once we describe, we register some functionalities so that we can, so that VL can lerp or like blend between our instances, then we will be able to use these generic functionalities that comes with Alchemix. And we will be able to blend or interpolate or compose our instance, basically. So I just pushed something into the I will push to the NuGet, but for now it's just in the repo. It's a new help patch that shows somehow already what could be the goal. And in this case, if I go to the definition of this patch, I have a custom data type, which is a particle, has a position, radius, and color. And then here now I will tell you exactly what do we need to register in order that, for example, in Alchemix, we have the functionalities that Alchemix can support, and what we need to do in order to register our type to Kairos, and what also we need to provide in order that we can see eventually in a timeline, for example, we can already see something. And as you see here, I'm already in this patch. I mean, this is not, it's not curated at all. It's just I did it like 1 hour ago. These are functionalities from Alchemix, the interpolator and the blender. And now, since I registered those functionalities, they can handle a particle A and particle B, and they can interpolate between them. You see now, the output gets interpolated. Same here, I can blend with additive mode, and they get added together, or differential will give different results because it's a different way to blend them. And again, I will show you what I mean. We need to describe what does it mean to blend these two, no? In which way. And once we do that, then here there's an example of a track where I placed 2 clips that now don't show anything because I didn't implement yet any visualizer for these keyframes. But still, these are dynamic keyframes that allows you to feed from the patch a value. In this case, I just connected these 2 particles there. And since I already implemented a visualizer, we should be able to see what does it mean to interpolate between the 2. So this is already working, no? So we just can place a particle in and animate like a narrative with it. So that's the goal. And maybe, okay, I guess, I don't know, do you want to go ahead and patch.
I mean, I could patch it, yeah, from scratch if you want to. You just tell me what to do.
If you prefer, you guys, you people, because it's, you can follow up. Yeah, let's do it. Okay.
Yeah. Then I will share my screen. Yeah, that's me. Do you see me?
Yeah.
Great. Just for everyone, I have now installed the latest version of Kairos, which Nathan pushed 1 hour ago. So this is now integrated in my installation via use repos. So if anybody wants to set it up also, and you have to pull it, I don't know if there's anybody who wants to do it and needs some help setting that up, or should I just continue and you watch?
You just show maybe in the settings of the Gamma launcher.
I also want to say just show it because others who read the CD record could be.
Yeah. So I'm starting with the Gamma launcher, the version 5.2, using the use repos option. And in the settings, I have set a reference to the vlibs and vlibs Kairos. This is basically where all the repositories that I cloned from GitHub are sitting. But for future people who watch this should not be necessary, because you will anyway release a new nugget with the help patch, right, Nathan?
Yeah.
Yeah. Okay. So that's the thing. You need to.
So I don't have this launcher at all. Do I need to set up this via libs and start downloading some things from GitHub?
Exactly. Yeah.
If you want to follow along the watch.
Yes.
Yeah.
Oh,
Okay.
wait for the nugget.
Yeah, I would. You can also. I mean. Yeah, wait for the nugget maybe. Yeah, and just follow along the workshop right now. Yeah.
Okay. So yeah. One thing. Okay. Maybe let's do it into this document, right? So maybe save it with a name somewhere.
Save as desktop.
Okay. Now we need to do the yeah, I think we need to reference Kairos first of all.
Mm-hmm.
Yeah. And I think this is not enough. So this is the first fishy thing. No, the only fishy thing is that wherever we define our data type and where we register the data type, that document needs to be a friend of Kairos. I don't know if you guys know what is. You can set like a patch. You can set a document as friend of a reference. Maybe shall I share my screen to quickly show?
Yes.
Okay. So basically, if we go here, if I right now there is only one way to do this. So from here I have a reference to Kairos, right? Otherwise, it shouldn't be necessary there. And the only way to make this friend of Kairos, first of all, what does it mean, friend? A document can reference another document, and just by doing that, you can see everything that is forwarded from that document, right? The problem is, in this case, is that there are many functionalities that are defined into that document, which are labeled, which are defined as internals, because we don't want to expose them to the final user. They are just very internal functionalities, so we want to hide them. So even if we forward the functionalities outside to whoever will reference that document, this patch won't see the internal functionalities that are defined into the document. Only if it's set to be a friend of that document, he can see the internal functionalities that otherwise would be hidden. So if I open with Sublime Text, I opened the text editor, I opened the patch where I want to register my data type. And if I go at the very end of the patch, there I can see all the dependencies of this patch. What I need to do is simply add this part of the code. So this patch was referencing Kairos, but only if I add this isFriend true, I can see all the internal functionalities of Kairos. So this is what you need to add, this part of the code. You need to add it to your patch. So now I can quickly put in the chat. Stop. So now go back to you, and you can basically do that. So say your patch is saved. If you navigate to the file,
Desktop, custom data type.
if you open it with a
Sublime Text.
okay,
So,
yeah, if you add this,
like this, right?
yeah,
okay.
Save it, and now you should just be able to reload from inside before. Just reload this patch, because you edited it from the file, so you need to reload from here. Did you reload already?
Yes, I stopped and
No, this is not reloading. This is evaluation.
Okay.
Yeah, okay, you can do this, or you can just, if you select the custom data type, go over the document there. Yeah, you can say reload. You see, after save as, there is reload.
Okay. All right.
In this case, you just reload the file from the document from the file.
All right. Yeah.
Okay. So now we are friends of Kairos. So, well, I guess the first step is to create a custom data type, right? This is your goal. So it's better to use a record.
I will just call it particle, right?
Yeah. Let's follow the same. Yeah. So there's a position, which is a vector 3.
Vector 3. Okay.
Yeah.
Radius.
Radius, float. And a color.
Control K, right?
Yeah, I would say so.
Okay. And now I do 2 instances of a particle over here, or?
So are we, okay, I would say let's keep some order, and let's put all the definitions in the definition of the document. I guess this is the application of the patch. So if we go to the definition,
Definitions,
and we put it there. So cut it from there and paste it there. Okay. For simplicity, maybe let's enable the process node of our data type. So if you go inside, no. I mean, like if you go inside the particle, just enable the process node so we can have and enable the state output.
Mm-hmm.
Yeah, and also the split.
Okay.
Why not? So that it's easier to handle these two instances in our patch. So now, yeah, if we go to the now we can place a couple of instances like that. Yeah, so
Fair enough, right?
so if you expose the inputs so that we can customize them a bit, let's just define two different particles.
One is red, one is blue. Maybe like that.
Okay. So we say that first necessary step is to make sure that Alchemix, the very fundamental piece of Kairos system, can manage this particle. So, which means like let's put there the basic node of Alchemix, which is in interpolator, right? You should find it since we referenced Kairos down there, the process node. Yes. This is because Kairos references and forwards all the sub libraries, no, the necessary things. So if you open the add patch of this, there should be one.
Oh,
What do you mean?
it's not linked.
Oh.
But what's
It's not in the Kairos. For sure, it's not here. Just Alchemix. Okay, what is in the interpolator node? Yeah. Okay, this is what we are talking about. No, just being able to lerp between two instances, just to. So the library comes already with some implementations for the basic types. But yeah, okay, we can close it. So this is what we want to achieve. Now, if you connect a particle to the interpolator, this will complain, saying, sorry, but something is not properly done. So if you open let's just use this help patch that I just made as a reference to understand what we need to implement. So if you open in the Kairos, yeah, there should be register your own data type help patch. Is that full? Yeah. It's basically it's done here.
Nathan, I have a question quickly.
Yeah.
Are the commits you pushed 1 hour ago, are they necessary to follow along, or did you just push the help patch into the repository?
I think there are some minor changes, for at least for the visualization part, not for the Alchemix part. So,
okay. So, but still, it should work if people are following along.
The first part, yes. This implementation of the Alchemix, being able to lerp and blend and compose your data type, yes.
Yeah, okay.
Nothing has changed there. So if you go to the definition
yes.
of this patch and enter into the Alchemix category and into the interpolation, maybe let's start with that. You see that the only thing that I had to describe, it was basically a lerp function. Why? Because Alchemix and this interpolator node under the hood, use this feature of the adaptive mechanism of before. So there is an adaptive definition, which is like a very abstract definition operation of what a lerp should be in terms of what inputs and what outputs. And then it's up to you to provide a correct implementation for your data type that describes exactly what happens when you lerp. So what we need to do is just define on our side and describe, okay, what is to lerp between our types. And we do it simply doing it with a function like this. So the way we can do it, I mean, we can do it. Okay, go back to your patch. And go to the definition.
Mm-hmm.
And so I would say create a category just to keep also this implementation in some order.
Oh, my keyword switched to English. Just this category?
No. Go back. It's the white. Oh. Yes, that one. Call it alchemics. So basically, this category then it's basically a subfolder, so to say, in which you can organize your nodes, and it basically introduce the name in the namespace of the category. Basically, add this alchemics. So if we go inside there, you see that on the top right, top left, you see that there is main.alchemics, and that will be the category of every node that we put inside here. So we'll allow to sort out things. So we need to create an operation, right? Which is lerp. So operation primitive called lerp. Yes. So it's important that we match the signature of this operation, because that's basically what this adaptive mechanism relies on. The signature is which inputs and outputs. So they need to match. Otherwise, VL doesn't know that it should consider our implementation as one concrete implementation for that operation. So I think it was input 2, and integral. There were 3 inputs. Input.
Yeah, it was 1 input.
There were 3 inputs. This one is called, so one is called input 2 with a space, input 2, and the third one is scalar, sorry.
Mm-hmm.
Scalar, which makes sense. These are the inputs of a lerp, so it's okay. And then there is an output. Wait, let me see. Let me follow up here. I have a patch here. Okay, and there's the output. Okay, so they are yellow because before doesn't know what to put there, right? But so we know what we want to do here. We want to describe how to lerp between 2 instances. So input 1 and input 2 should be where we feed the 2 instances. So what do we need to do then? We need to split our instances and then handle their properties, each one with a split. Just connect it there. Split also the other one, because no one except for us know what does it mean to lerp between 2 particles. So we need to describe this. And I guess what we can, and then the output should be another particle. So we need to, out of what we do in the middle, we need to create a new particle and feed it as an output. Okay, then in this case, what I did also in the example, I simply lerped between the inner properties of our class. So I took, yeah, the lerp, first one, yeah. And you will just connect the position of the first particle and the position of the second. And that will be the position of our outcoming particle, and the scalar is is connected there. So you can also bring the scalar close to the lerp, and then duplicate both. You can duplicate multiple. You can just select together. So just a quick delete the last two scalars.
Yeah.
And select the lerp and the scalar together. And duplicate them.
But like this, right?
Yeah, yeah.
Oh, no, actually.
And again, yeah. And then we connect them accordingly, to the properties.
Mm-hmm.
So that's for the color, and then radius is there. So now this lerp will provide already a description of what does it mean to lerp our data type. Cool. Now, if you go back to the application patch, and I guess you need to recompile. So right-click in the patch, recompile.
But this is in the help patch.
Yeah, close the help patch.
Yeah.
And you might have.
Yeah,
so if you start now, patch.
No, it doesn't. It's not possible to start.
Recompile then. Recompile again. Because it crashed. Recompiler.
Okay.
Okay. So now the interpolator doesn't complain anymore. So check, is there an output? Yes, there is. Create an IO box or a split, I don't know.
Oh, yeah. Is there a way to quickly expose all inputs and outputs of a node?
You mean create an IO box for them?
No, just a shortcut that is making an IO box for all the outputs.
I don't think so. I don't know.
Okay.
So, but yeah, if you tweak the scalar, now we should be able between 0 and 1. Yeah, it works. We are lerping already between these two instances. And now, automatically, by default, the interpolator uses a linear interpolation. But now you can use all the interpolation modes that comes with Alchemix, which is like, for example, twin interpolation, model. And then you find like twin, for example, where you can decide, the kind of interpolation you want. So, yeah. Okay, it's already working. So this was the easiest, I would say.
What I don't get right now is why this interpolator node is now knowing that it also can work on this particle definition.
Because we defined the lerp for that type. And this lerp function is the only thing that is required in order to operate with the interpolator. You see, in fact, that it's getting used. So Alchemix picked up all the possible implementations of this operation and found that, there is one for particle. So I can use it, so I can do what I'm supposed to do, thanks to the fact that we defined that locally. And that was the only thing was necessary, because at the very core of Alchemix interpolation, The only really thing that matters is this lerp function, and all the rest comes for free, basically, all the different kinds of interpolations and methods and models. So that was the only thing that was necessary for the interpolation part. Now we need.
Is it happening because we call this one alchemix?
No. That doesn't mean anything. So what matters? I don't know if you're familiar with adaptive with adaptive mechanism. It's basically. Let me see if I can show you. Let me check. Maybe I can show you with a plus.
We don't see your screen right now, or is it?
Yeah. Sorry, I'm just checking. I was wondering how can I show you maybe damper. First, I want to make sure that I can show you. No. What could be a node? I just want to. What could be a node to explain this? Not math. Noise maybe.
Is it because of the name and the amount and names of all inputs and outputs of the operation?
So if you go to the main patch here, I will show you, and open the interpolator. Okay, now we are there. Go one level up to the definition.
To what?
If you go to the definition.
Yes, yeah.
So, and open the interpolation. Why is red? I don't know, whatever. Then you see that, for example, there are this type-specific frame there contains all those categories where I had to define some of these functions for those types in order to enable them. For example, if you open the Boolean, I had to define a lerp because it didn't come with VL, because it doesn't make sense to lerp between two Boolean values, right? But if I wanted to provide functionality also in Kairos, also for Boolean, so I had to implement this, and I found my own logic there maybe to implement. So what matters is that I define, I create an operation which matches the name, so it needs to be called lerp. Doesn't need to be advanced. Here is advanced because I wanted to hide it. But what matters is the name of the operation and the signature. So if he has the same name and the same inputs and outputs,
yes,
with the same exact name, then it can, the adaptive mechanism can make use of it. And in this case, the lerp definition, actually, yes, of course, this already is the simplest thing. No, fucking hell, wait, why? I can't open, maybe it's, anyway, the lerp, the original adaptive lerp comes from VL itself.
Yes.
Because VL, you see it when you create it in the patch, in any patch, it's an adaptive node. No? As soon as you connect a vector or a float, it replaces that temporary node there with a concrete implementation for that type. But that means that in VL, somewhere in the core lib, probably, there is an implementation for each of the VL types, and the adaptive mechanism just picks one of them. And we are simply providing another new concrete definition for our data type. So it gets picked up in the same way that the other get picked up. So the adaptive mechanism just recognizes that, yeah, there is, when the compiler just compiles the code, then there is an implementation of the lerp function for that type, and then it uses. So that's what matters, the name and the signature.
So basically, if I would have called my input here, input 1,
or whatever, call it even with a different name, I don't know, just blah, blah, foo.
it would have not worked because the names and the
Exactly.
of
If you
inputs
go back,
don't match
if you go
the
back,
definition.
if you go to the main patch, for example, and now recompile, probably,
Yeah.
you will see that it will complain immediately.
Okay. Cool. Yeah.
So need to change the name input. Okay.
Yeah, nice. This is something I wanted to know also, but not today. It just turned out that this was taught today. Yeah, it's a really nice feature.
Well, yeah, it's very powerful, adaptive. Huh? It's crazy. Something that needs to be embraced. So, okay, this was just the interpolation, but if you place a node in the patch there, which is the lerper, the blender. Blender is the other main node that comes from with Alchemix that blend between two instances. So if you try to connect it now to our nodes, so this will work probably because yeah, it's easy, but because the default blend model is basically passing through the value, so it's not doing anything. That's why it works. But if you put like let's put some blending model, like so if you go to Alchemix, blending model, additive, for example, it will for sure complain. You can say, okay, now I really have no idea what to do with that, to be honest. So what do we need to do? Go back to Alchemix document.
Their category.
No, the vl.alchemix document. That one, yes. Go into the blending category. And here you see that these are all the techniques that gets used here in the Blender section. These are the blenders, really the one that operate. So if you open the normal Blender, first one, which was the default, there you see why it was working, because it was just passing through anything. So it's easy, for sure it will work. But go back and open.
Just making some. Where to? To the definition, to the application?
No. In Alchemix, are you closed? Okay, interpolator. Go to the definition.
Sorry. Blending?
Blending, yeah. If you open the additive blender, second one, you see already that this guy operates using an operation which is adaptive. Here there is just a definition of this adaptive operation, which is called add blend. So in order to be able to use this additive blender with our data type, we need to provide the definition of what does it mean to add two instances of our type. So then we probably need to define this operation for our concrete data type. So if you go back one level up with the arrows, use the arrows, it's easier.
With the arrows, okay, yeah.
But do you have a 5-button mouse?
Yes, but I never navigate like this through.
What?
No.
Really? It's just I don't know how can you do without. But anyway, if you go, we are in blending, no? And if you go to no, on the left, first column there, type specific. There you see all the implementation for all the types, common types there. For let's say, open the float 32 category. Here you see that I basically defined all these operations that are used inside the blenders. I described for this type, for the float 32, what each one of them needs to do. Okay, so and so that's why I can use a float 32 and I can use all those blenders. So I would say the easiest thing, just copy all these operations to our document.
The custom data.
Yeah, let's just use it. So if you go into Alchemix, I would say maybe create a category. It's better to keep things sorted and put blending. Sorry.
Mm-hmm.
Yeah, go inside and paste everything. Now go back, just for clarity. One with the arrow. Okay. Right. Create another category and call it interpolation. Yeah. And move the lerp inside. It's really important to be organized, guys, because this is a very simple data type. Mm-hmm. But maybe later we'll show you. Yeah. Anyway, blending.
Yes.
So now, well, these operations are defined for the float 32. We need to come up with our own blending for our type. So I would say we need to do something, intuitively, no? Like add blend means that we need to add 2 instances. How would you do that?
So basically, I will just. This is typed now.
Yeah, you can remove the type.
But I can also set it to particle in this case.
Yeah, but it will be inferred by the nodes that you probably need to use anyway.
Okay. Yeah. But basically, we have one particle. We split both again and we just sum everything, right?
Makes sense. Makes sense to me.
Yeah, okay. And the value is also another particle?
Yeah,
okay.
These are the 2 instances.
And now we just sum everything, yeah. Right?
Wait, and then what needs to be the output?
A particle again.
Yeah, exactly. So I will leave it to you for a few minutes, and I'm coming back. You need to basically create the logic, right, for each one of these operations.
Okay.
I'm coming back. Good luck.
Is this now a group activity or a breaking?
I think this is a group activity now. So who's doing the subtract, multiply? Yeah, this is actually. Can I just add 2 colors, or should I do something else in between?
Is there a use the mouse on the same screen feature on Zoom?
Sorry?
Is there a use so we can all use our mouse on your screen via Zoom?
That would be awesome, right? Yeah.
Or we could just treat this like watching someone play solitaire and be like, "Ooh, do that there."
Yes.
Oh, he didn't do that.
Okay.
Like a sports commentator.
Yeah. But can I just sum 2 colors, or should I do something else? Yeah, basically I could do this, right?
I think you should use the square root. Sum the squares.
Nah.
Now multiply and then the squares, otherwise the divide.
You need to sum the 3 values of the size, the vector, and the color together also.
Yeah, so I'm doing the manual labor right now.
It's like you are counting and we're shouting random numbers at you.
Yeah. I need to.
We were helping.
Ah, no, not plus, minus. Am I really doing this now? Float 32, right? No, that was a vector. Yeah, let's just do it. Vector 3. Where's the vector 3?
So, yeah, I mean, we don't need to do everything, right?
Yeah, thank you, because this is boring.
No, yeah, no, just I wanted you to make a couple of them in order that we can test, but
Let's just
you know,
do maybe the minus, and is there something else that is interesting or so?
I would say so. I wanted to check. So go ahead and put and connect the output.
Just these two?
I would say there's a trick that we can use.
Okay.
For example, look, check the overlay. For example, it's very complicated, no? The overlay, the bottom, yeah.
Ah, the overlay blend.
Yeah. How you want to do this? So what I suggest is I already implemented the overlay blending for most of the main types. So maybe we could use those implementation inside this other implementation.
Yes. Okay.
It's a bit of a trick, no? So if you overlay blend exactly, and you use main, no, what is it? What did you choose? Okay.
And for vector 3,
You
right?
don't even need to choose the specific implementation. I'll show you. So keep the inputs there.
Sorry?
Keep two of the inputs so that we can.
Which inputs?
So background and value, obviously.
Ah, yeah, sure. And everything else I can just delete.
Yes, I would say so.
Okay.
Okay, now maybe copy from one of the implementation that you did, the split, and just click. Yes. So now, yeah, what needs to be different is just what we're doing in between. So if you type overlay blend, that one, and choose the main Alchemix blending, this, no, this is our, sorry, delete this one. Again, overlay blend. We need to pick the, I guess, no, generic, the first one. Yes. So this is the generic implement. What?
This is referring to itself, I think.
Oh my God. So maybe create set a version, write a version into this operation here. But I don't think so. Overlay blend, the name of the operation.
Sorry, there?
Yeah. Add in brackets, add particles. Particle. So we define the version of it. Should I don't know, but so overlay blend, try the
This
first one.
Generic?
Yeah, the generic should. Interesting. Okay, it's not that. Choose another one then. I don't know. This is weird. Shouldn't do that. Maybe it's wait. Overlay blender. Down. That one. No. In the middle. Overlay blender.
Ah, this one. Okay, yeah.
Okay.
This is the one that you
Yeah.
searched.
Okay. Now, this is the adaptive one that will just find the right implementation because there is for sure implementation for all these types.
Yeah.
And it was just a trick. So I would say all the others. I mean, yeah, you can maybe remove all the others that we didn't implement, so that we don't, and the compiler doesn't get confused. Right? Okay, so if you go back to the patch, to the main patch.
Not this one?
Yeah, this one. Sorry, recompile.
Ah, yeah.
or you need to play the patch. If it doesn't play, you need to recompile again. I guess it's a 5.2 issue. Yeah. So yeah, it works. As you see, if you disconnect the additive blending model,
yes,
it goes back to the default, and you can do the subtract. Yeah, blending model. No, go back model. What was it? The overlay. Yes, we had an implementation for that. Yeah, something is coming out. Okay, so
and just a question. So all of these, they can now be what's the one that we had before? Okay, copy. All of these can now be connected flexibly because they share an interface. Yeah, this iBlending model.
Yeah, of course. This is the way these nodes work. This Alchemix, both the interpolator and the blender, also the compositor, which is the third node of the mystical triangle. They all get basically configured by these nodes, which are models that describe really what kind of interpolation, what kind of blending, what kind of composition you want to operate. Okay, so that's it. So basically, we already. So if you put also the compositor node, which is the third node of our the one. Try to connect the first. Yeah, as you see, we didn't have to define anything because the compositor in reality is just a combination of blending and interpolation.
Yes.
So automatically it also works because we describe the functionalities at the interpolation and blending level. Cool. So basically, we already implemented our data type with for Alchemix, and we can use Alchemix to do whatever we want with it. Cool. So the next good news is that we don't need to define anything for layer X because it really use adaptive mechanism inside there as well heavily, and it's very polished and basically it provides all the functionalities out of the box as soon as you implement definitions for Alchemix. So what needs to be done now then is implementing, registering basically these. What's happening here? In a minute. Yeah, we need to register this type to Kairos. So in order to do that, if you go to the definition patch, there is a functionality for this. First of all, we need to use a feature of VL, which is called register services. Basically, you can create an operation. Sorry, you need to create a normal static operation, and you need to call it register services. So make a primitive, and then call it register services. Exactly. So any patch that has this name will be called when the patch loads. Okay, will be called once, and that's a way that we can use, for example, to let's say that we have a factory where we want to register some functionalities. We can do it on even before the patch starts to run. Basically, the first thing that happens is a call to these operations here. So inside these register services, so whenever we open this patch or another patch references this patch, this operation will be called, and from within here we will register our type to Kairos. And there is a functionalities for that, which is called register Kairos type. register Kairos type, yes. And you just need to provide the type, an instance of it. So maybe create a particle, put a particle create operation, and just fit it there. What really matters is the type, that it picks the type. That's it. Okay, so this is already available to Kairos. And that means that, yeah, it's already working. So this is the only thing that needs to be done in order to use any kind of type in Kairos. So what is the next part? We need to operate with Kairos, and we do it through editors, through UI. So we need to make sure that we can visualize, and the UI can correctly draw we can draw these types. The cool thing is that if we are not interested in the UI and we already have, we could potentially build a timeline using nodes that contain some instances and some particles, and we could already use it, like sample it, and it would work. But if we want to visualize it, then we need to register some other stuff. So yeah, in our patch, let's maybe create in the bottom of the patch, let's create a timeline.
Okay. Underneath. Okay, all right then.
Yeah, let's put the basic nodes.
That's
Timeline, and then a Kairos editor. Okay, so in the Kairos editor now, we can also create like a window there to edit the timeline.
Mhm.
So if you go to View, New Kairos node, and then select the timeline in the patch, and there you go.
Anybody needs to repeat that step?
For any questions, first of all? Any doubts or curiosity? I spent years literally just trying to make this process easy.
Yeah, it's too simple.
Okay, so yeah. Now let's see what happens when we do this. So if in the timeline, let's create a track. If you go to create track new, there is a bug, I think, because there you see there are some spreads that shouldn't be there. I will take care of removing them. But at some point, there is particle. There is, right? Yeah. Choose that. Give it a name. And create. Okay. Nothing happens.
Yeah,
No.
sometime.
Wait. No. It's because it probably didn't manage to visualize this track. So, and that's why we need to define certain things. So at this point, maybe I can show you on my side what needs to be done.
Then I will stop sharing.
Yeah, because it's more screen one.
Would you think of a little break? 5 minutes?
How long are we planning to do in general?
I think we are pretty, I don't know, another 20 minutes.
Okay, yeah, then let's just push through. Yeah, okay.
Yeah. So, okay, I'm looking at this help patch that I made. And as you see, we have the data type. This is the Alchemix thing that we already implemented, right? And then there is this one to register the type to Kairos. And then I made another category here, I call it UI, where I define some other stuff. I will also clean a bit So, but in general, so for example, one thing that I want to, yeah, these are two things that we need to define, which are again like same principle. Wait, this shouldn't be generic. Okay. These are again some concrete implementations, definitions of some generic operations that are defined into Kairos. So we just need to provide a definition for our data type. This is a custom default, which will be used as the default of our type. And zero, what does it mean zero? Zero, when you think about zero for float, it's obviously it's zero. Vector 3 is 0, 0, 0. No, that there is this adaptive node in VL, and I'm using it in the UI. So that's why we need to define what zero means for our data type. So I could have just placed these inside like that, right? My data type is just the zero is simply like the default values of a type and of my data type, and custom default as well is just my type itself, the first thing that comes when I create it. But in this way, whenever there is a node or where it has maybe there is a pin which gets the default would be constantly created now because it's a create. So imagine that this default gets called and it would get created constantly. So this is just an optimization that I did, which is basically I created a default particle data type where I create a particle once and that's it, okay? And then I simply can split it. And then I defined a singleton, single instance, where I collect that instance of the particle. What does it mean? That whenever someone calls this function, it will call basically this, and all of the calls will point to the same instance which got created once.
Oh.
Okay, so this will be called once because just the first one that calls this operation will basically create an instance of this singleton, and after that, everyone else that needs that default particle will just simply get the same result. So we avoid constantly creating new values, new instances. Yeah, it's just a memory optimization, so to say. But this is just basically was to allow this optimization. And then there are these two implementations that we need to provide. And then particles monitor. What's called? So if I hit play, you'll see in the timeline, whoa, didn't react nicely to that. So in a timeline, the preview of the value is visualized here. No? It can be like a vector, whatever, but this is called monitor. It's a monitor of the value, okay? If I want to see something, I need to describe and so say I need to register a monitor for my data type where I describe how to draw my monitor there. And that's what I do here. I have a class which is called particle monitor. I call it whatever, which name I want. And inside this class, is fairly simple. What's important, it needs to implement I-value monitor, because we need to implement this interface because we are a value monitor. And so this is how I register this monitor for this type, for particle monitor, for the particle. I simply can use this operation, which again, always the same mechanism. I'm using the adaptive mechanism everywhere in Kairos, sorry, because it's a very easy and flexible, powerful system. So here I defined a class implementing a certain interface that comes from Kairos. And then, thanks to this operation, I register it basically and say, okay, whoever the UI, the timeline UI, will call this, will make use of this node, this creative value monitor UI in an adaptive way. And the track of the timeline will ask, okay, I need to create a monitor, a value monitor for this type. Do you have VL an implementation for this? And then, since we describe it here, we define it, yes, VL will be able to pick our class here, because you see that this is the create of this class we registered, that we created. So this is just to say, okay, if someone asks for a value monitor of this type, then please take this I-value monitor, which is this class that we define here, because here we know what to do with that. In fact, this is a value monitor. This is the input value. This is how the monitor works. It simply gets the bounds, which most likely will be, these bounds. And we need to decide here what to draw inside it. So in this case, I just pick the center, and I use a draw. And I'm taking the radius from the circle and the color, so that we can see something. But you can come up with your own whatever way you want. I'm not visualizing the position, for example. We could potentially say, okay, you know what? Just also offset your position with the one that comes from, maybe multiplied by a small number, because the number were big there, I think, So now we are also using the position of the particles to offset this circle. So probably we will see it moving. It doesn't seem like, but it's moving. The center of the circle is moving. If we want to be precise and want to visualize something, let's just do this. Should be easier. Okay, so we are moving from there to there. So you see, but what I did is I simply described into this particle monitor how I want to visualize this. I want to represent an instance of my type. That's it. So in order to, for the timeline track to work, I also need to define this adaptive operation, which is a bit cryptic. So I would suggest to you just to copy the entire thing into your patch, and simply the only thing that changes is this value that needs to be a spread of your type. I will put some comments in the help patch. Once you describe this operation, then the track of the timeline doesn't complain, and you can deal with the type. So that's basically it. Obviously, you might say, it's a very basic representation of my type, and I totally agree. So the next step would be to define, which I didn't do yet. So maybe we can have we can have an addendum to this video. I don't know. Because you can define, also visualizers at the keyframe level for your type, or you could describe and define visualizers for the interpolation in between. Unfortunately, I didn't have time to make an example for that, but this was just the basic thing in order to allow you to already work with it. And so that what I'm doing here again is simply like I'm creating keyframes, live keyframe values, so that we can, from the patch, you see there will be another instance here, so that we can input something there. In theory, this is something that we do it live now. I didn't try. So now, yeah, if we go back, you see this is the default basically of the particles, which is size 0, position 0, color white. It goes there. But if we create a constant, let's see if it doesn't freak out. If we create a constant value and we select it, we potentially, yeah, we can edit the value of the circle directly there because there is an inspector. So if we go there and we say radius something, color whatever, green, and position a bit, I don't know, here, there. Okay, that's our color. That's our new instance. So we can edit, thanks to the fact that this is like an object editor, so it can basically edit this record, this data type, very easy. Okay.
Could you also put in some live value into the circle in the live layer in there?
Ah, right. So let's say, for example, that we set the color. Let's do this. Oh, come on. Yeah. Let's say that we want to change the color of this one, right?
I meant the live value from the outside, the third pin on the timeline.
Ah, okay. Well, it's the same. They're both. I mean, this one.
Yeah.
All of them are live values. Let me restart. So now I go on the, this is the third one. And I can, from this, so now this particle, is changing its color. So we are interpolating from here to that one, right? And then back to the other one, which we described as a static value here.
And also all the the interpolation. I know we
yeah, of course. Yeah, these are keyframes of the timeline, no? So if you go in settings, you find interpolation model, right? If you go to twin, we can choose, I don't know, in bounds or elastic, whatever. I don't know how much. Yeah, we can see it already. Toon is bouncing there.
And all of this is just possible with this register, with this, what was it before? The register function.
So all this interpolation is possible thanks to the fact that we register the type with Alchemix. And then here we are really simply using it. Yeah.
Is it now, Anatan, is it now also still already possible to record stuff?
Yes, of course.
Wow.
Yeah. I mean, this is simply another channel. So if we go, I still didn't try all this, but if I make a channel, like a global channel, for example, global channel, very important particle, and we create, oh Jesus, let's just help ourselves. Oh, yes, don't worry. You know what? Let's just do this. Okay. What's going on? So I use a little bit confusing. We don't need to see anything. Okay. I guess it's probably the compiler freaked out. Let me just, let's see if he recovers. But in theory, I mean, you know, global channels, you can have an instance, no, that goes over global channel, where you have a channel containing this particle. The compiler decided to crash because I changed the class probably. So
No, in short, I tried once very quick to use Kairos for recording the Connect class. And now I see I have to then go to all values. And in the end, I wrote an XML file. But now I see I could now use the records from the Connect, also recording what's coming in.
Yes. Yeah. I mean, do you want to like, do you want to record like a stream of the Kinect skeleton as keyframes in the timeline?
For example.
Yeah, you can.
Yeah,
you can register like, if you record your Kinect instance as a Kairos type, then you would have instances like keyframes of that type.
yes.
And you can record it, of course. Yeah, the record mode in Kairos is nothing special. It's just an helper way to create keyframes for you by using global channels. So yeah, you should be able to use it.
Yeah, this now what you showed is much more handy when I go through this process, and then to disassemble everything, have a lot of lines. Most of them you use normally Kinect Studio. But what I wanted to have movements like snippets and then play it back different, so that you record something. And now I see it's possible when it's recording, easily done. I will try it out now later if I can go through your process, what you showed now with Kinect. Cool.
Okay. So yeah, I can maybe let me show you what I wanted to since there was this topic, I started also to implement something that potentially is really cool, which is like, for example, imagine if you have textures as type, if you have texture. So Kairos can become like Adobe Premiere, if you think about it, because if you can interpolate between different streams of textures, different videos, and compose them on top of each other, and triggered clips, video clips, and can be quite powerful. So I wanted to give it a go, and I created a separate. Which screen are you looking at? What do you see? Wait, screen share. Yeah, this one. Okay. I created a separate package for that because I don't want to bring all the, if I want to register texture means that I need to reference Stride, but I don't want to, and that was the point of having this very flexible architecture. I don't want to register every type, so I don't want to, from within Kairos, I don't want to reference any possible library that we are using before. It's just unfeasible. So that way, now I have a separate package that you will install later when I will publish it. If you are interested in using Kairos with textures, then you will basically install this NuGet, which is Kairos Stride, which eventually will also implement entity. Sorry. So you could have like tracks of entities, Stride entities, and you could build scenes in that way. And you could interpolate between scenes if you describe that, no? So that's why it's Stride and it's not Kairos texture, because I want to support all the types eventually that comes with Stride. And if I open this one, this one is an example of a way more complicated implementation than the one that we did. Mainly because the texture, and it's still not completely done, texture is a very complicated data type. First of all, it's not only like a simple class or whatever. It also, the way it gets used by the system is very complicated. So I chose it as another example, like an extreme example. But what you can get in the end is probably, let me show you. First of all, I implemented LayerX for textures, and so we can use all of this now, simply. All the different blending and interpolation methods with it, between, to interpolate between two textures. And then I also register it for Kairos, so that I have a keyframe here, and I can interpolate this other one, as you see. So this is already like a mixer, so to say, a timeline for textures, and keep in mind these are live inputs. So yeah, does it work? I never use this stuff. I don't want to do it, but I could use my camera stream inside one of these keyframes. But in order to do this, I had to work a bit harder, because, like in Alchemix, for example, in the blending, I had to implement custom blenders. Instead of simply, if you remember in our previous example with a very basic data type, the only thing that was needed was to define this lerp function as an operation, a stateless, so a static operation. Here is a bit different because I need to use shaders. So additive blender, for example, I need to use, these are shaders. I just wanted to use texture, like texture effects, to handle all these composition, no, these blendings. So for that reason, I had to register this class itself as the blender, as the interpolator. It's a bit more deep, a bit more advanced than using the other method. This gives you really the full freedom of also implementing like a stateful blender or interpolator, and you can really do everything. So yeah, it's a bit more advanced interpolation as well. For now, I just implemented these three. And again, here is another texture effect. So I had to define the interpolators themselves, the classes that get used by the system, instead of implementing simply the operation. If I show you, Archimix. Yeah. So this is we are in Alchemix interpolation. So what we define, what we registered for our type was like, this, no, the lerp function. And that was enough because we didn't need any stateful complex operation. And what happens to this operation that we define here? It gets used in this linear interpolator, which is the standard interpolator. As you see, this is the class that comes with Alchemix that implements our interpolator. And it makes use of the lerp. So for most of the types, basic types that just where it's enough to register like a lerp function, this is completely fine. So at that point, on your side, you will just need to register this stateless static operation, and that's it. If that's not enough, like in the case of the texture, where you need to really have a stateful process like a shader, then we can't use this standard implementation of the linear interpolator, So we need to register our own linear interpolator for the texture. And that's exactly what I did there. So here I define my texture linear interpolator, where I created this class and I say, okay, it's an interpolator, and this is how it works. So these obviously are this is an operation that comes from the interface, and I put there my shader, and then I registered this class as an interpolator. So the interpolator node in Alchemix at some point will need to create a concrete instance of an interpolator to handle a certain type. So it will use this adaptive mechanism to find a correct implementation for that type. And thanks to this, we register that, okay, yeah, if you need an interpolator for texture, here, this is what you need to create. And this is the create of our class here. So in this way, we are registering this class specifically to handle texture. And this class then will be used instead of the standard linear interpolator that comes with Alchemix. That's it. So
could it have been possible that the linear interpolator had the same name, or why did you append texture?
It can have the same name. Yeah.
Okay, because you call the texture linear interpolator, but
yeah, it was just for my
clarity.
Yeah. The only thing that really matters is the again how you register it. this is what really matters is the signature. So this is the adaptive mechanism that will get considered whenever you need to create an interpolator. Okay, what's the type of the input and the model, whatever. The type and the model, very important, because this is the class that will handle the linear interpolation model for texture. So we need to define both types so that the adaptive mechanism can basically pick exactly this one whenever you need an interpolator for a texture with a linear interpolation. And that this can be called in any way we want. The important thing is because Alchemix itself doesn't even see this class or doesn't consider the name or whatever. Just consider, okay, you just ask to VL, I need an interpolator. You please use your adaptive mechanism and just give me one if there is. That's it. And then it doesn't care what's the name, because after that, it just used the interface to operate on these classes. So, yeah, very complicated answers for very simple questions. Anyway, is there any question?
No.
Perfect.
Now.
Yeah, of course. You need to give it a go. And as I said, this was just a very basic implementation without getting fancy with the UI. But yeah, of course, you could implement your own super crazy visualization of the particle or the skeleton, whatever, and that could sit inside your keyframe. Or so, for example, for the texture, what could be done is between the keyframes, you could have like snapshots of the texture or of the transition, and that could be like a custom defined interpolation UI. So, yeah.
Yeah, it's super powerful, the whole concept. It's so crazy how you can then, from this high-level tool, how you can define, again, yeah, fine-grained things, and they automatically appear in the system. Yeah, it's crazy.
Yeah, it's powerful and sad that doesn't have enough boost.
Yeah. But it was also for me the first time I really get a use case, or I see something for adaptive type or a mechanism. Categories, a register. I was okay, new word, new thing. Yeah. But it's amazing, crazy. And then now I need a 5-point mouse.
Please, yes. When you start using it, there's no way back. It's just there's no other way to navigate before at the moment.
I actually use the Node browser a lot, but not between tabs.
But if you want to navigate through the tabs, how can you do it otherwise?
I click on them.
No, but I mean, if you want to go inside and go outside and navigate, I mean, looking to the tab when you have many tabs open, it's a mess.
Yeah, totally.
I mean, so from here, I go to the definition, and I get inside here. I'm gonna get to Alchemix. Then I go back. I enter here. I go back. I enter here. I get inside here. I go back. I enter this other one. I mean, try to do the same choosing the tabs. It's just impossible. At least you have like a path now that you can follow. It's like a tree in the end, the representation of the patch. So you can go inside, go back, enter another branch. Sometimes, most of the time, it's way faster than sticking the tabs.
Well, I guess I now have a use for these extra buttons on my mouse I've never touched.
Please, try.
I just was.
Okay, so yeah, that's it. I still didn't try in. That's fine. I didn't try in the matrix in the launcher. So shall we? I have no idea.
I wanted to say thank you because I have to leave. But great again, Nathan. I wish you the best.
Let's see.
But if it's in the recording, we'll get it.
Yeah, then have a good evening. Yeah.
Good evening. Bye. Just because I want to hurt myself just at the end of this presentation. Let's see. So if I create a new, okay, launcher. Sometimes I'm mind blown by the fact that it works. So I create a new track, which is the whatever, which is texture. I create. So let's see. I create a new clip, live clip. Okay. Then I create another clip, which is B. This is electricity. So I probably need to register. So it already works, but we don't see it because.
Would it be the same preview as in the timeline down there, or?
I know what. Sorry, it's a quick fix because I had to change this into the. No, so I will use. My superpowers to reach exactly what I need. Track, output monitor, there you what? There you what? Here, okay. Custom default, right? That's it. I guess now if I stop, let me just recompile. Yeah, it should work out of the box because we define a monitor, and the monitor gets used in both the timeline and the launcher down there to visualize the value. Okay, so yeah, it should work as a demonstration of the fact that the underlying architecture in Kairos is really the same. So, and it doesn't. Okay, so maybe I need to check. It might be something else that I need to tweak. But if I sample track, maybe we can see it this way. This T and it's a texture. Okay, then okay, I still need to fix that there. Good. Now I know. Which is what? Okay. Yes, maybe I picked the wrong one, sorry. Because here I defined a custom default, right? Custom default. This. Yes. Let me compile again. Yeah, I mean, yeah, I can't think about it. I mean, it's a bit of a dead project, Kairos, at the moment, so it's a bit frustrating to think about it.
Yeah, that's people should consider donating again and keep up the Open Collective.
Yeah, they should. I mean, well, I need to check. Oh no, okay, let me configure this. Wait a minute. Let's check. Yeah. Sorry, I'm just checking. Yes, okay.
Oh, yeah, there it is.
Yeah, there it is.
Wow.
You see, no? Boom, boom. So, yeah, as I said, also settings, let's say 2-second interpolation. Boom. We interpolate that. Right, let's just put like a chessboard. Okay. Boom. And we have a video mixer right away that we can use together with all the other parameters of our systems. And this is like a preset. As I said, it's just frustrating for me at the moment. But I hope that people will realize more and more the potential of this. And the only way to support, really, the only way is to finance the research, because I'm broken. So I can't afford anymore to work for free on this. And I mean, this could literally be a full-time job, considering how many things we could do with this and how many features we could implement. Starting from very basic keyframe interaction like multi-selection. These are all things that can be easily implemented with time. And this should be really like a community project, and can't be a personal project anymore. Yes, that's for sure. So yeah, I guess that's it.
Yeah, Nathan, thank you very much for showing us around, and yeah, it's it's getting more powerful with these functionalities, really. Yeah, for me at least. Yeah, because then it's exiting the user perspective, and you're getting deeper into the system, and it's really powerful like that. At least it's what I think about it.
Yeah. I mean, we could even think of having like a series of these kind of workshops where I can show you other parts from the developer point of view.
Sure, yeah.
Where, for example, we go more in details about implementing UI keyframes for the timeline or this kind of stuff, more in details, or yeah, going in the direction of having in mind the direction of, okay, maybe someone else of you guys can want to contribute, or to expand the team. I don't know, but yeah, let's see what's the interest, and we can plan accordingly.
Cool. Yeah. Then I will stop the recording, right?
Yes.
Thank you very much. And yeah, so this will land on YouTube. So in any case, if people stumble over it and see this, consider donating on Open Collective. And yeah, hopefully see you next time.
Yeah. We should drop. We should put the link maybe in the video. The link to the Open Collective in the description of the video.
Yes, it will be in the description, definitely.
Okay.
Cool.
Great.
Thank you very much. See you soon.
See you soon. Bye.
Thanks. Bye.